So we've talked about Coulomb's law, but does it apply to everything that we look at, big or small? Probably not. So there are some stipulations that must be met in order for Coulomb's law to hold. First, we're assuming that we're looking at charged bodies much smaller than their distance of separation r. Next, we're assuming that the force is going to be inversely proportional to r squared. But this raises two questions. First, how small is this very small in the requirement? We know that charged bodies obviously can't always be a point or a speck. So how did Coulomb know that the electrostatic force was inversely proportional to r squared and that it was actually accurate? So these were actually experiments that were done by Henry Cavendish. You can read the notes for full details, but the experiment was optimized and repeated by Maxwell about a century later, and he concluded that the error was about 10 to the negative 6. But nowadays, we know that the error is approximately 10 to the negative 16, which is many magnitudes less and many magnitudes more and amazing. So the better question in modern times is whether Coulomb's law will break down at certain separation distances. So we're no longer looking at whether the relationship between f and r squared is an inverse square. We already know that it's accurate to the order of 10 to the negative 16. Now we're more worried about how big can r get before Coulomb's law doesn't work, or how small can r get. So there are actually two known limits. We have an upper bound and a lower bound. So electromagnetic theory goes down to 10 to the negative 16 meters, and after that it might not work. But the magnetic field of Jupiter with the Pioneer indirectly confirmed, Pioneer 10 indirectly confirmed that Coulomb's law at a distance of at least 10 to the 8 meters worked. So we know that this astronomical separation distance can work for Coulomb's law as well. So now we have a scale to work with. We have boundaries at 10 to the negative 16 and an upper boundary at 10 to the 8. For the purposes of this course and the field of engineering, there are bounds. These bounds are more than enough for the development and usage of modern devices. And although Coulomb's law describes forces accurately, that's pretty much all it does. We want to be able to change our perspective and look at fields. So electric fields, magnetic fields. It's not until you look at Maxwell's equations, so all those equations that were presented and unified by Maxwell, that we can actually make sense of electricity, magnetism, as well as light all in one big picture.